Hello and welcome to the solution to the problem of the day that was posted on 7/25/2026. The problem was prove that the curl of B is equal to the Levi-Civita tensor times the covariant derivative of the component, the vector component, times its basis vector, reduces to just the partial derivative of the vector component with respect to the coordinate J. Okay? So first thing we want to do is expand our covariant derivative. We know how to do that. You always write down the partial derivative of whatever you're differentiating. In our case, it's bk with respect to the coordinate j. Since this is covariant, we pick up a negative here, right? Write down our Christoffel symbol. When this is negative, the summation index always goes high to low, high to low. We've got two covariant indexes, jk. Now let's expand this inside. So it looks like this. Now let's break this guy out and look at it. Okay. So the J's and K's are both summation indexes, and we can swap them if we want, right? Perfectly legal. We've done this many times. So I'm going to swap J for K and K for J. I swap K for J and J for K. Okay? That's the first thing I did. The second thing I'm going to do is permute this Levi-Civita tensor. So I'm going to move J back to the middle, back to the middle. That's one permutation. So it's odd. I'll pick up a negative. Now, you notice here I didn't do anything here because you can't permute this. You can only permute this, right? But what's unique about the Levi-Civita connection coefficients? Remember that? They are symmetric about their lower indices. Remember, they're symmetric about their lower indices. So I can just put them back because that is equal to that. So I've got this is equal to this. What? Well, how can this be true? It can only be true if they're both equal to 0, right? Nothing else is going to be true unless they're equal to 0. Thus, this expression, that just becomes 0. So we're left with this. It's just the partial derivatives is left. Okay, wasn't that fun? I'll see you later.